Okay, great. Thank you very much to Dipkanu, Kalyan, Rishu for joining this discussion. Thank you to people who participated today. We know it's May Day, it's Labor Day, but let's have some fun, and hopefully this will be a fun conversation. I think firstly it's customary to mention that Dipkanu is joining from the US time zone, and therefore it's about 11 p.m. at night. We hope that this will be an entertaining evening, Dipkanu. So we'll take it up from here. Let me quickly make an introduction to what's RootConf, what's Hasgeek, and why we're all gathered over here. RootConf being a platform for SRE and for operational and for DevOps. Over the years, we have engaged in what I can confidently say are fairly candid conversations on how do you manage infrastructure, how do you look at questions of running teams, how do you look at infrastructure as being tied to business, and this being the case, how do we look at tech practice, how do we look at teams? You can learn more about RootConf by going to hasgeek.com/RootConf and checking out videos of the past. I highly recommend that after this session, please go and watch the Kanu talk from RootConf 2016, which was on chaos engineering. I think that's still a super hit talk that we've had over the years. What we also have today, over the period of RootConf running since 2012, what has also happened is that we've formed a sort of a peer group among some people who've been speaking, who've been reviewing talks, and I think among the reviewers present today are Rishu Mehrotra and Kalyan Sundram. Thank you very much, folks, for joining in. This event is hosted on Hasgeek.com. Hasgeek.com is a platform to bring geeks from all genres together to have conversations like these, to share experiences, and more importantly, to learn from our peers. Hopefully, some of this will result in us forming peer groups where we can have banter and chatter about SRE. So do keep visiting hasgeek.com to get updates on events like these and on people like Dipkanu, Rishu, and Kalyan. Having said that, I'll just quickly introduce the format of the event today. We'll start with Dipkanu making a short presentation about the current state of affairs and his perspective. We will have Vishu and Kalyan respond for about 10 minutes to this with Dipkanu chipping in as well. And then we'll open this up for questions. So feel free to post your questions in the Q&A tab over here. And we will take these up during the question answer session. For those of you watching from YouTube Live, we're moderating and watching questions there. So do post your questions there. We will pick them up from there and put it up over here for the AMA session. With that, I'm going to go back to my home scenario. My cat has decided to sweep the house and my daughter decided to have her day started. But I'll hand over to Dipkanu from here. Dipkanu, please feel free to introduce yourself and then take us from here.
Hey, thanks, Zainab. Hey, everyone. So I'm Dipkanu. I work at Facebook on pretty much like at this point I think I've worked on like many different things, but primarily on large scale distributed systems, network systems, and these days I'm working on AI infrastructure, specifically deep learning systems for speech and audio systems. And I think last time I gave a talk on with Hasgeek, it was in 2016, and since 2016, a lot has changed in the distributed systems space and systems engineering space. So when Zainab talked about this event, I thought about doing a talk on not just SRE but trends in distributed systems and trends in making systems reliable. So I'm going to do a short presentation, and everyone else like on this call, please stop me and let's make this as Q&A focused as we can, and let's make it like as interactive as we can. All right. So when we talk about reliable distributed systems, or in general distributed systems, I like to begin with what are the metrics of success. In my opinion, the metrics of success are availability, latency, and reliability. Availability because we expect our systems to always be live. Whenever we take our phone out, like we want those systems to be up and running, and we want these systems to be as quick as possible, to be as less latent as possible, because I think latency is perceived correlates with user experience. And lastly, reliability influences the bottom line of the businesses for which we build those systems. Like if you're building an e-commerce service, I mean, if people can't add to the shopping cart, I mean, people are not spending money on your website. If people can't send text messages, if you're building a chat application, people are probably not going to be like engaged or going to be using the platform. So to me, like when it comes to figuring out like how well we are doing as an organization or as a discipline, like these are the things that come to my mind. And and the tools that we have today, like at our disposals, the top ones at least, like which comes to my mind when I think about starting a new project or like developing a new system, are obviously like first of all, like I think about public clouds, and not just having public cloud in the market where we are operating, but across all the markets in the globe where our systems or our services are going to be available. And then content delivery network. Until like maybe like 5-7 years back, like there used to be a very few content delivery networks, and the idea of like using a content delivery network was not very prevalent to distribute assets, like digital assets like photos, music videos, or things like that, was not even very prevalent because there were only a few content delivery networks, and because of that they were very pricey, and hence people were not thinking about such things. But with public clouds, content delivery networks is sort of like becoming democratized, and they are also becoming cheaper. And with that, I'm seeing like a lot more people, a lot more applications using those CDNs, which are very close to users. Then I think about structured logging. Metrics was sort of there, like even like 10 years back or 15 years back. Like back in the day, if you followed the blogs of Etsy, like you would hear sort of like metrics and monitoring sort of like humming. And I think metrics and monitoring were sort of like rose along with like the DevOps movement. Like in circa 2008, 2009, like people started talking about measuring everything that moves. But now I think the trend is moving from just measuring everything that moves to like traces, and also like to do like structured logging. I think there are systems like Honeycomb right now, like which sort of have made structured logging very popular. And tracing has been sort of made popular by systems like Zipkin, for example. And like a decade back, we were still not talking about microservices as much as we talk today. And as people have adopted microservices, people realize that there is a need to understand like how each of these systems are fanning out to each other when an end user request comes in. And that made tracing popular. And so today, I think tracing is fairly democratized, and people who need tracing can have tracing. And systems like Envoy, systems like Istio and stuff like that, they all support tracing. And I think which is like the good part is when the tools that you use to send traffic or to like move traffic in your data center support tracing, then tracing comes for free. Another nice thing that happened to us is eBPF, and I'm personally super excited about eBPF. Operating systems were not as visible to systems engineer as they are today because of eBPF. Back in the day, even like a few years back, like I would look into sysfs or procfs to look at what the kernel is telling me about the health of the system. But now I can load an eBPF program dynamically into a running kernel and probe the kernel data structures and find things like which application is making a syscall, or how is like the network interface behaving, or if someone is sending me a packet, I can write a custom eBPF program which can short circuit like the chain of packets that comes from a network device to the application and sort of like short circuit it that way. And last year I wrote a paper on how personally I am using eBPF to build systems, and it was published in Usenix login. So if you have Usenix, take a look. And I generally think like eBPF is really exciting, and it has sort of like changed the whole landscape of instrumentation of operating systems in general. Cluster schedulers, I don't need to talk much about it. Everyone uses Kubernetes these days. But I think even then there is a change in pattern of how people are using cluster schedulers. 6-7 years back, when we were developing cluster schedulers, people would tell us that they're rewriting their applications in such a way that they can run them on cluster schedulers. But I think now we are going in the other direction a little bit. There were still like certain systems which were hard to write on cluster schedulers, like databases or persistent systems. Now cluster schedulers are application aware with things like Kubernetes operators or at Facebook, Tupperware has something called the task controllers, which are linked here. And those kind of things allow you to codify running things like a database or a system like Kafka on cluster schedulers, which was very hard to do, like even 5-6 years back. And lastly, a lot of systems need data, and they need data in such a way that it could be useful to train deep learning models and so on. And there are systems now like workflow systems. Dagoba from Netflix, Lyft recently announced a workflow system called Flight. With systems like that, you can easily write reliable data pipeline systems, which take data that you already have and then extract features out of those data, and then allows your training algorithms to ingest those data. I think as AI and machine learning becomes more and more prevalent in products which are exposed as web services, we need reliable data pipelines as well, because most of these machine learning or deep learning models actually improve like how well our online systems are doing. And so let's talk about like availability and reliability patterns that I'm seeing over the last year or so. As I said, there is public cloud available pretty much like in every major market. So when we develop a new service, obviously we think about how do we make our service available in every market. And one quick way to do that, provided there is enough resources, is run those services in every market. So if there is a tsunami in market A, like people in market B can still access the services that we provide. And not just that, with more regulations and things like that, as laws about data changes, it's very important or very essential or very like useful to have a global presence. In that manner, like you can have policies which are very specific to a given market. And with having services in every region, there is a need to load balance requests from users, from end users to those services. And that's where I think global load balancing comes into the picture. So let's say like I'm running services in Europe and US, and for some reason the deployment in Europe goes bad. In that case, having global load balancing systems move all the requests to the US sort of like saves the day. And again, this used to be harder back in the day, and there are things now like Route 53 and so on, makes it pretty easy to like move traffic from one region to another. Third is having spanner-like distributed persistence. Until like a couple of years back, when we talked about having availability in our data systems, we would talk about systems like Cassandra, for example, like which would have replications between data centers or between regions and so on. And people thought systems like MySQL or Postgres or relational databases, which do not have capabilities of reliable data replication across over the WAN, is going to sort of fade away. but those systems were also pretty more user friendly or programmer friendly to use. Now I think we have come with spanner like data systems. We sort of like are in a good spot where we get like all the reliable data transfer between regions, but we also get the programmer friendliness of having like acid like semantics or relational semantics in our databases. So for more use case, we can have a distributed data store without giving up on the things that we liked in non-distributed data stores. And we almost all of us have seen like outages on major public clouds where a single configuration change had brought down the entire system. And for that, we need more phased rollout of code, right? When we roll out code or configuration, we don't want like all our systems which are running in different regions to be impacted at the same time. We would like to see like whether system is behaving well in a given cluster, then to like a given data center, and then to a region and so on. So start deploying code and configuration in the smallest blast radius that we have, and then from then like gradually increase the blast radius. And lastly, I like to think about federated control planes, sort of like changing the game. Control planes are pretty difficult to build, like reliable control planes. If you have worked on systems like Paxos or Raft and understand like the challenges of maintaining a system which uses Paxos or Raft, then you would sort of like see where we have gone from circa 2013 to like 2020. Like back when I was working on Mesos in 2013, we used to suggest that run all your Mesos masters, which is like the control plane of the cluster scheduler, in one data center and distribute all the agents in the other data centers if you had more than one data center. From there, we have come to a place where we are running control planes in Kubernetes in every single region. And users don't even know like to which control plane their request to launch a job is going or to launch a container is going. So we have, I believe we have come a long way from that perspective, is to have like federated control plane so that we still can talk to any of the control planes and control like all the other systems that we have in other regions and data center. In terms of reliability, I think the trend that I see, which is most prevalent, is using client-side load balancing, like smart client-side load balancing. Like even until a couple of years back, we used to talk about load balancing in the perspective of like Nginx and HA proxy and all other systems like which were fairly traditional, right? Like someone would write a policy for load balancing and then the load balancer will act policy. But now we are seeing systems where the clients which are sending RPC like become smarter. Back in 2004 or 2006, I think I read a paper called Tail at Scale, or maybe even earlier, like 2002, which was all about smart load balancing, which was about reducing the 99th percentile latency, right? And if you have a general load balancer, like a Nginx or whatever, reducing 99th percentile latency sort of becomes harder because then you don't really control at the client side the semantics of an RPC. With client-side load balancing, you can do like things like parallel requests. Like if you have two services running Java or Golang or any of those managed runtimes, if one of them decide to do garbage collection, you would see a jump in 99th percentile latency. But with hedge request, you send out many requests at once. And then whichever server responds the fastest, you take that response and show it to the user. So with that, like 99th percentile latency like reduces a lot. Those kind of things, I think, were not available until like recently, as you know, like as things like Istio and so on became popular. But now we have those tools to do things like that. Flow control over the network is another such thing. We used to talk about TCP and TCP level flow control. So if like a producer and a consumer, if a producer is producing a lot of data and the consumer is not keeping up, usually the solution was like, you know what, let TCP do its thing. and then over a period of time, the network is not going to let the producer send so much traffic. But now, like with reactive systems, with reactive load balancing systems, the application can provide the users, or the producers can provide the consumers can provide the consumers producing data some back pressure, by which like the producer sort of like backs off, and then we don't overwhelm the network and the application. So those kind of things are more popular, and I think more people have access to it. And so when we are building new systems, I would imagine like we would build our new systems using such technologies. So pretty much this is like what I had, and in terms of like trends in building reliable distributed systems. Do we have questions or things now?
Sure, thank you, Tanu. Rishu, Kalyan, over to you in terms of responses.
Hi, I hope I'm audible.
Yep.
Great. So this is enlightening. Thanks, Deeptan. And I think a lot of these systems and patterns that we talk about are now becoming part of the industry as and when we are going, right? However, there's always one other aspect of it, which is the people who put these systems together and behind the scenes people, right? There are, I remember having a chat with Kalyan a while ago on this. And it was that, hey, every time we put together a system, it is a certain combination of some paths that we see the system going, and then there will always be an outlier that will cause an outage, or that will cause a problem that the system will probably not be equipped to handle it. And when we talk about these very key aspects of availability, of performance, how do we kind of also ensure that how do we have that feedback loop, that if there is any incident, how do we track that? How do we make these systems even more and more adaptable? Yes, machine learning is one way. And I think, we are truly heading towards what we would call as a Skynet age, right? Absolutely no danger in that. But thoughts on how we actually run and maintain these systems, because when we say, okay, this is how a system has to be architected, has to be put together, has to be thought about, more insights on that. And the second part that I would always have is that when we talk about independent geolocation independent systems as well, where we say that, hey, it's super awesome to have systems where the client doesn't even know where the request is being handled from. How do we kind of, do we take the same metrics, or do we kind of have a model where even the teams working on these systems can use that model and correlate it to these metrics? Because that, even in the times that we are living in, that's a very pertinent question for all of us.
Yeah. These are very good questions. So let me answer the last question first, because that's like I remember it the most. So to me, like I feel like every system boundary needs to be well instrumented, right?
Mm-hmm.
I'll go to like an extreme here. On EC2, for example, like if you're running an application and the application is using the file system, chances are pretty high that the system is probably going to be writing to elastic block storage, right? Which is a network file system. And with anything over the network, right, like I would imagine the latency to be sort of vary during the course of a day, or even during the course of like a short period of time. So I think like every IO request in that case needs to be instrumented. Now you would think like, I'm using a POSIX file system, right? Like POSIX file system API, like how do I measure like the performance of the POSIX file system? Because back in the day when POSIX file systems were created, like 20-30 years back, like there was no monitoring or metrics or instrumentation. But today you can. You could use eBPF on Linux, or dtrace on a Sun microsystems or not Sun anymore, but you know what I'm saying, like Open Solaris or whatever, right? Dtrace or something like that, or on a BSD kernel, and measure like how well your POSIX APIs are doing. So that's like an extreme example. But let's say like a microservice is doing like RPC requests to like another service. No matter where those RPC requests are going, like the boundary needs to be very heavily instrumented, right? Like if I'm a team running the microservice, which depends on 5 other services, like on my dashboard, the first thing I would see is like how well are my dependencies doing. And when during an outage, like that's the first thing I would see. It's like what kind of errors am I seeing, or what kind of latency am I seeing in the dependencies, from the dependencies of my system. And I think okay, first of all, like, does that make sense?
I think that's fine. Let's keep going on this. I think it's a good way to kind of see that how somebody in those shoes would look at what metrics to look at, dependencies and so on. But I think the question goes a little deeper in the sense that when we're going to have people operating these services, and obviously there is going to be an outlier and an outage, how do we kind of build models for teams to work? Just like remote systems, you also have remote teams, right? And it's a very different kind of a challenge when, in terms of availability, in terms of time zone, in terms of knowledge, asymmetry, these things come to the fore, right? And unfortunately, they usually manifest themselves when things are down in the dumps at times. So how do we kind of enable and empower teams to come up with a model that ties in these key system metrics or these key metrics and say, hey, this is how we can even build teams that function better, like the site reliability engineering.
Right. Yeah, I mean, I think like the protocol needs to be laid, right? Like if you have built a team, and if you care about reliability, like sort of like thinking about what happens when a system fails or a dependency fail, like that protocol of like what do we do as operators of the system when something is perceived to be slow or something is perceived to be not available, like what are the protocols that we have, right? And if I simplify it further, it basically means like having a run book which people follow, right? So that like if you hire someone tomorrow and if they don't know much about what is going on, like there is a protocol laid in front of them. And we also have to have like some escape hatches in the protocol. For majority of the, for even if like a person like sort of like solves majority of the problems in a system, like the escape hatch could be how does the team member get help, right? Like what do they do like to communicate effectively how much they have looked into the problems, or how do we communicate in the first place that there is a problem, right? When someone tells us that something is broken, we need to understand like what is broken, right? I think that's the first step. And like that's like the first step of the protocol. So like we design our protocols in such a way where we streamline incident response, right? We streamline how do we like react faster, right? How we streamline our protocol to react faster. So things like that, I mean, that's something that like I would do, like mature teams would do, to sort of like make it easier for people to work with the systems that we are building.
Sounds good. I'll let Kalyan have a quick go. So taking all the time around here.
Thanks, Rishu. So, primarily the conversation, Rishu covered most of the conversations we both had. Primarily, the situation, so this whole conversation started, I'll give some context behind it, where the context that is working with distributed systems really affected during a remote work scenario. So that's the context with which we started. So our systems are anyways remote. Our systems never needed us close to them. We always access them remote, and we always treat, leaving diplomacy, we always treated them as cattle. So if one system goes down, if we couldn't reach, we make sure our availability is not affected. But that's the same level of thing is possible. Sorry, that's the same level of distributedness work when teams work remotely is something that question that cropped up to us. Yes, processes to some extent will definitely, the processes is something that will help us. There are the reason why the processes are not coming up. So we had some more conversations on why the processes are not coming up, or does everybody have a process? So some of these things that came up to our mind. So I will just list them here. We will. I think we can go around seeing how it is implemented or how what are all the starting points for people to implement. So one of the things that came to our mind is if a process is being brought in, how do we measure that the process is working? So some things like, will it be like, do we measure the process is working, like how we measure systems uptime, how we measure systems availability, or how do we measure it? Is there a way that we measure it?
I mean, in my experience, whether it's distributed or in person, I think the yardstick of measuring success of how well we operate our systems is, I don't think it's like how many nines we have. I think how many nines we have is sort of like developed over times, over a period of time as we make our systems more reliable. But in terms of how effective our process is, in terms of like how we operate our system, I think the yardstick for measuring success on that front, to me at least, is mean time to react, right? There are various mean time related metrics. One is mean time to debug. What that means is how quickly can we debug our system, right? And before we go to like other things like mean time to recover and so on, is like, I think I like to think about how quickly have we figured out the steps that we can take, the steps that we can take to alleviate the user problem, right? So often, like, what happens, I think, is when we are working in a distributed manner, communication, I think, sort of like is what is becomes crucial, right? If you and I were in the same room, uh, and versus like we are in different continents, the main difference is communication, right? Visual communication and so on. So with working remote and being distributed, like visual communication sort of like goes out of the window unless like we are doing video conferencing and so on. But during times like an outage, I think the key to like working remotely is to communicate very well, is to express like what is the problem, what we are trying to solve in a very crisp manner, so that like whoever is solving the problem or everyone in the team understand the current state. And from there then on, sort of like figuring out a protocol to sort of like how do we debug. And after the incident is done, someone has to record like how long did we take to sort of react to first the outage, how long did we take to sort of understand like what is happening, and how much time did we take to sort of like alleviate the user problem. So I think if you have a timeline of things that happen during an incident, right, I think that's the first step towards measuring whether we were good or not. Once we have a good timeline, then during an incident review, you can discuss like how well did you do as a team, or how well did we do as a collective in solving an outage. I think two things. First is like an incident timeline, and second is like the incident review, sort of, in my opinion, which can be used to measure.
That makes sense. That makes a lot of sense. Yes. So one another thing that came up is if we have to actually bring up a change in the way So what you said makes a lot of sense. Primarily, communication is the key. Secondly, you have to have a post mortem of how you do things and do a course correction if something is needed. So this has to be a practice in many places. If it's not a practice in place and bringing it, there will be always some resistance to adapt to the change. Primarily because people think this might not help or something. So there has to be some amount of evangelizing that has to happen. So is it do you have you faced an evangelizing kind of thing, or do you think the metrics itself will speak for it and it's just make sure the process is running?
I mean, fortunately, I have always worked in places where these things were in place. Um, so I personally haven't set up a program like an incident review program, but they were already in place, and I was lucky to like sort of go in and observe and be a part. And whenever there is an outage, like I would present the story of the outage. But if I had to do it myself, I think I would sort of like refer to what John Allspaw talks about incident management. It's like sort of creating a safe environment for everyone, and sort of talking about the fact that incident review is just not to sort of like understand like how well we did as people or as humans. Incident reviews are also like a place where we talk about how our systems are going to evolve in the future. I have always found that incidents like which were very hard to tackle, or incidents like which were not good or we were not proud of, led us to make evolution in our system architecture, in our system design, and so on. We talk about making data-driven decisions when it comes to building systems or evolving systems architecture. Incident reviews are a good place to sort of like present our case of why our system needs to evolve. So I think like making as an environment like that where the focus is on improving our system and processes, I think is like a good start. But having said that, I have not done it myself. Like I have not set up a program. Yeah.
So Kalyan, that's actually a very interesting question. So just taking a minute off it. So I've had some experiences in setting up similar processes, right? Where how do you do incident management processes? And yes, this is where the people aspect compared to a system aspect comes in, right? To give you an instance, there was one of the scenarios where we were having a system where we had multiple missed assemblies, right? And then we said, okay, what do we do to collect data to show how bad it is? We said, let's start filing incidents for every single SLA miss that happens. All of a sudden, the number of incidents we were filing went up by like almost by a factor of 80, like by almost, I don't know, more than 100%, because now everything was getting filed. Were we capturing all the data that we said? Yes, we were. But at the same point in time, from a people aspect, that process was very taxing, because every time you file an incident, like Deeptan, you said, there's a mean time to response, there's a mean time to resolve, right? There's an incident control. So it took a toll on the engineers who were actually on those incidents, because you would have multiple incidents at the same point in time, right? In a heavily distributed system. So setting up these processes, I think the scalability of the model itself comes into the picture. Looking back at it, this was some years ago, looking back at it, when I feel about that process, or when I look at that process, I realize it was a very data-driven, very systems process. Asking a bunch of systems to kind of do that versus asking a bunch of people to do that is a very different ballgame altogether. And I think a resistance will always come till people do not see an uptick in their daily lives. For example, if I'm making a system better, but it involves the SREs or the engineers on board to probably work instead of 10 hours, work 20 hours instead of, let's say, 8 hours, then obviously it is not going to be a model that will become very effective, right? Because you will see pitfalls elsewhere. So it's a very interesting problem domain in itself, that how do we create models, right, for systems and for people, right? And I think it would be good to have a chat on it some other time as well. But just letting my own experiences on, putting my own experiences on the table.
Got it. Yeah. I think Nilesh has some question. Nilesh, do you want to pitch in here with your questions?
Yeah, we'll just Nilesh, just hold on. We'll yeah, you can pitch in now. Nilesh, you can unmute yourself and you can speak your question or the comment you want to make.
While
Nilesh,
we
can
wait
you?
for,
Okay. I think as we wait, Nilesh, pitch free to cut me off. So from my point, one another thing. So before this talk, we had a very interesting discussion that distributed systems are it really affected due to this whole COVID remote work scenario. So I think what one of the positions that I had is we are not generally affected badly because we most of our works can be done remotely. Most of the problems that an SRE in general face is pretty much similar to any other problem that happens. Oh, some of the nice points I brought up are communication. We have to be exactly to the point. When there is an outage and the war room is right now virtual, you have to actually be properly communicating so that the people are not touching each other's toes. And second thing I find that is challenging is we have to build a community because when you meet persons in office because if you see this presentation today, it's like 5 years the landscape has changed, so the tech is kind of changing. So you have to constantly have with your peer group some discussions on how things are handled, how it's kind of like you have to have yourself updated with what things are happening. So probably when you work remote, uh, so it depends on the person's availability. Some person might get time to do a catch up, some person might not. So that can be off that was earlier getting offset once you have a workplace where some kind of time is spent on intellectual conversations with the peer group. So I think that's something also we have to have. We have to actually spend some time having a peer group, be it virtual or something, so that we stay updated.
yeah, absolutely. I mean, the social angle of, I think like social angle is pretty important, and sort of like talking about like like how systems are being managed and how we evolve our systems, and if someone has a good idea of of doing a new project. I mean, if you are having those conversations near the water cooler or during lunch, I think it's important to catch up with coworkers. I certainly do, and talk about even like what I'm hacking on like in my free time.
We don't have any questions yet on YouTube Live, and I'm not sure if Nilesh is able to speak out what he had raised his hands about. I
I
also
think
see
there's
Achal. Yeah.
I see a question though. I see a
Oh,
question
okay.
in Zoom. So here it's from Ramki. How do you keep your teams updated from the competency perspective? Do you have playbooks, run books available? I think it's kind of covered, but I think I think it covers two aspects. One is the tribal knowledge. How do you make sure there is no tribal knowledge and it's distributed across your team? And will just playbooks and run books take care of that? Uh, Dipan, do you want to take that?
Yeah, I mean, for sure. I mean, again, like I think that's a pretty good question, and like as I was talking about this, I mean, like part of like laying down the protocol is like having people know where is the knowledge base of like knowledge base of how the system works, how the system is built, how the system is getting deployed, how do you manage traffic to the system, and so on. Where pretty much like every knob that is there in the system, like to manage and operate it, there needs to be a knowledge base, and the knowledge base should not live in the head of people, right? Because then like we end up in a situation where, you know, like we depend on people, we depend on like the collective knowledge of like of a group to resolve a production issue and things like that. So from that perspective, like I like to think about it as, if I develop a feature and there is a knob to manage it, I'm going to like document the knobs when I'm putting this in, before I put this in production. And when it has gone into production, I advertise it to my coworkers. I say that this is a new feature that has gone into production, and here are the knobs of how you are going to manage and control like the feature. If you need to turn it on, this is how you turn it sorry, if you want to turn it off, this is how you turn it off. And if you want to change some configuration, these are like the steps to change the configuration. So that's something like I personally do, and I would imagine that no matter whether we are remote or not remote, like this is something that we have to do to keep our systems up and running 24/7.
I just saw Zanuj's message. Hi, my name is Achal. Uh, yeah, I think um, having a good culture around this is kind of like the most important thing that you can set up when you're setting a new team or when you're trying to build all of this process out. One thing that we've done pretty effectively is that um, whenever someone new joins the system, joins the team, we expect them to dog food either the like service that the team is responsible for or whatnot, and to discover um, all of the gaps in all of the documentation that's been written so far because of feature drift or whatever. And then collectively as a team, we try to figure out what the answers to these gaps are in documentation so that we can plug them. So yeah, I think, you know, to what Diptanu was saying, I think having a good culture around um, making sure that all of this stuff is well documented is pretty important. Just to introduce myself, my name is Achal. I'm a software engineer up here in Seattle. I used to be at Uber for like 4.5 years. I worked on their infrastructure, SRE stuff, and then I also worked on their machine learning platform. We've operated like a bunch of machine learning infrastructure at scale at Uber. Very recently, I changed jobs, and I'm now working on a startup in the data ML space, building feature pipelines in a feature store for small to medium businesses, like onboard all of their feature transformations onto. Yeah.
So did you like work on hoverboard, Michelangelo, and those kind of systems?
Yeah. So my team owned Horrorword and Michelangelo. So Michelangelo is a pretty large team, but yeah, my sub team owned Horrorword and a few other things in like the deep learning infrastructure space.
Cool, pretty cool stuff.
Cool. We have roughly about 8 odd minutes before we want to close. No further questions yet from the audiences watching live. But I suppose, yeah, if you want to do like a wrap up or a summary, this might be a good time.
So, Rishi, do you want to take it? Or?
Nah, I think that's good right now. Nothing much.
Okay. So yes, so the one of the things I want to bring along with the documentation front is, yes, as a new joinee, it's usually the practice to give the documentation and then see how it's still valid in today's world. There might be feature drifts and stuff. So it becomes really difficult when you onboard a new joinee at this point when everybody is kind of work from home. still so I think it's not difficult. It involves more effort because you could have again, it boils down to the communication where you can't have a one-on-one whiteboarding session. It becomes again a virtual session where, once sometimes I feel the people lose the um, same emotional touch in the questions. Questions gets refined. Certain questions are pushed down when you have to put them in, when you have to know them and then ask a little later than walking to a person and then talking to him. That's pretty much I want to that friend.
Yeah, that's fair. I think so. In my last month or so at Uber, when I actually had to onboard a new engineer onto our team, we faced similar issues where it's hard to get communication right because you're not meeting in person and you've never met this person like face to face. I guess I don't have a magic bullet here. The only thing that you have to do is you just have to try harder and you have to make the effort to go the extra mile to make sure that you're creating like an environment where questions can be asked and that you can connect with folks. It's yeah, there's no magic bullet other than you just have to go the extra mile to make sure that you over communicate and you add on the side of, you know, soliciting more questions and soliciting more comments and feedback from folks when you're onboarding new people, just to make sure that you can answer these questions and have folks be productive sooner rather than them having to hold on to their questions and then having to come back to these questions at a much later time.
Makes sense. Yeah, so it's, everything boils down to how we communicate. To put from another perspective, the systems have evolved faster than how humans communicate to this situation. So I think there has to be, now it's time for humans to, we spend time in making the distributed systems work well. It's time for the humans piece of it to catch up and, work and keep the systems up and running. Even though the whole team is distributed, there is knowledge gaps and stuff. So there has to be, processes which fill that piece of it. There's one more question I got on Zoom. It's like we could probably add it if we have it on hand, or later we could. I think the presentation will be shared. We could probably put it there. So the question is, what blogs or go-to resources you refer to from regular reliability point of view? So,
like personally, I don't really read a lot of blogs these days. The Google SRE book was pretty good, I think, which came out a couple of years back. I think they have a new book now. I think they're pretty solid. Back in the day, I used to read Etsy's Codescraft. I don't know if it's still good or not. I mostly read like papers from conferences and so on, and that's pretty much like how I would keep myself updated. And I read ACMQ. It's a magazine. I think it comes every few months. I read Usenix login as well once in a while. LWN is a good resource if you want to learn about systems engineering and just generally about the kernel stuff. On the data science front, really, I think there are a bunch of like medium blogs, or Distill. Distill is pretty good. That's pretty much it. Yeah, I mean, I don't know if I would like to hear what everyone else is reading, actually.
I feel like if you follow the right people on Twitter, you can tailor your Twitter experience to be heavily focused on systems and distributed systems. That's basically what I've ended up doing.
That's true, actually. Yeah, that's true. But if it's just distributed systems, honestly, like Eurosys is a good conference to follow. NSDI is a good conference to follow. Like most of the interesting work which happens or which comes out, I think like lands in one of those few conferences. OSDI is another good conference. So.
yep, that's quite good amount of resources, I feel. I think we are done. If we have no questions, I think we could wrap up.
Sure. I'm just checking once more if there are any questions on YouTube Live. No, I think everyone is waiting for your slides with Tanu. I need to figure out what is that gold mine you are but yes, we'll put up the. Well, so I think everybody is waiting for your slides. The only questions on YouTube Live are whether we're going to get the slides. So I suppose there's some gold mine hidden there. So with Tanu, we will have to make your slides public and we'll get in touch about that. So thank you very much. I think this was an interesting conversation. We should definitely catch up privately and chat up in terms of how we can continue to have these conversations. I think these are important issues of our times. While tech is tech, I think the fundamental issues really boil down to culture and organization. Thank you, Achal, also for joining the chat. It was really nice having input from you. And Dipanu, we hope you have a good night's sleep tonight. For those of you watching us, it's hasgeek.com where these conversations, these events, and these peer groups are happening. So do sign in, do join up, and do tell us what you'd like to hear more about. We're listening. We're happy to put things together for you. Thank you, Rishu and Kalyan, for moderating this, and have a good day with the rest of you. Bye.
Thanks, everyone.
Thanks a lot, guys.